In this video, I will be going through some TYS question. The question which I will be going through is 2017, paper 1, question 15 and 16, as well as 2016, paper 1, question 25. So let's take a look at our first question. Triangle ABC has an area of 52.08 cm squared. AC is 15 cm, BC is 8.4 cm. Part A asks us to calculate the perpendicular height in centimeter from A to CD. So what is perpendicular? Perpendicular means that a right angle. So basically it is here, then it is right angle. And to be honest, it could just be A to B and it is right angle. We do not know because we do not know whether this is a right angle triangle. So at the moment, let's just assume that it is a straight line that form a 90 degree with BC. So how do we go about doing this? Since we are given the area is 52.08, we know that area of a triangle is half base times height. So the base here is 8.4. Okay, this one is equals to 52.08 because half base times height is equals to the area of the triangle. So we just write down half times the base, which we know is 8.4. 8.4. The height is what we are interested in finding. So H is equals to 52.08. Okay, this one is part A. So this will give me 4.2. H is equals to 52.08. Next, I will bring the 4.2 over. H will be equals to, this one is 4.2 times H. Times I move over, it will become divide. So 52.08 divided by 4.2. So the height will be 0.08 divided by 4.2. It will give me 12.4 cm. And this will be my answer for part A. Part B asks us whether ABC is a right angle triangle, and we are supposed to show and justify our answer. So let me just bring it over here and change the color. Now, for it to be a right angle triangle, we need to apply Pythagoras theorem. We need to see whether 15 square minus 8.4 square, the square root answer, to see whether it will give us 12.4. So how do we go about doing this is, we know that Pythagoras theorem is a square plus b square is equals to c square. Now, 15 down here is our c square, while 8.4 down here is our, let's say, b square for simplicity purpose. So what we want to find is AB to see whether it is equals to 12.4. So we bring our b over. Our c square will be 15 square minus 8.4 square is equals to 154.4. So a square is equals to 154.44, and a is equals to square root, because square we move over becomes square root 154.44, and my answer will be 12.427. So if you ask me, this one is to 5SF. It is close to be a right angle triangle, but since the answer is not 12.4, is not an exact 12.4, so since square root of 154.44 is not equals to 12.4, because it's equals to 12.427 blah 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 blah, triangle ABC is not a right angled triangle. Alright, so it is close, but it is not there. For it to be a right angle triangle, the square root of c square minus b square must be equals to the height. It is close to the height, but it's not exactly the height. So therefore, it's not the answer. Next question. One is using a ladder which is 4.5 meter long. She put it against the wall so that the bottom of the ladder is 1.2 meter from the wall. The safe working angle for a ladder is between 74 and 76 degree to the horizontal. Is the ladder in a safe position for Juan to use? So for this question, basically they are asking us what is this angle, because they want to check whether it is between this 74 and 76 degree. So this is rather simple because we have learned our tua, ka, so. Alright, so with respect to this angle, 4.5 is of course the hypotenuse, 1.2 is of course the adjacent angle. So I have A and H. Which one do I use? I use cosine. So cosine, let's call the angle theta, is equals to adjacent, which is 1.2 over 4.5. So how do we find theta? We need to get rid of the cosine. So the cosine we move over. When we move over cosine, it becomes cosine inverse 1.2 over 4.5, and this will give me inverse cosine 74.5 degree. And this one is to 1 decimal place, which will be my answer. So this statement is actually important since the angle 74.5 degree is, we need to write here between (74 degree and 76 degree. The ladder is in a safe position. Alright. Okay, next question is this. The diagram shows a piece of card. AD is 6.3 cm. AB is 8.4 cm. BD is 10.5 cm. BC is 12.3 cm. CDB is 90 degree. We are supposed to calculate angle BCD for part A. So angle BCD is down here. This one is our part A. So this is actually quite simple because we have this angle down here. 12.3 is the adjacent side, 10.5 is the opposite side of this angle. So when we want to find angle, we can actually use our tua kaso. So we have O, we have A, our tua ka, and so we have O and A, we use tangent, alright? So part A we use tangent, this is BCD is equals to opposite, which is 10.5 over adjacent, which is 12.3. So we want to find angle BCD is equals to the tangent we move over, it becomes tangent inverse, bracket 12.3. Now you may realize that just now I did not bracket. It doesn't really matter that much, but calculator, you remember to close the bracket inside your calculator, alright? If not, you will get some error. So this will give me 40.5 degree, and this is to 1 decimal place. Alright, and this will be my answer for part A. Let me change the color. For part B, show that ABD is a right angle triangle. ABD is a right angle triangle. This one very simple. So for it to be a right angle triangle, it must follow A square plus B square is equals to C square. Now you have 3 lengths over here. You need to know which one is which. C is the longest length. So which one is the longest? It is 10.5. So we want to find out whether A square plus B square is equals to C square. So very simple. 6.3 square plus 8.4 square. What do I get? Is equals to 110.25. Then we check whether 10.5 square is equals to 10.5 square is also equals to 110.25. So since 6.3 square plus 8.4 square is equals to 10.5 square, this statement is very important. This part down here is very important that you write this kind of statement when they ask you to prove whether this one is a right angle triangle. Since A square plus B square is equals to C square, you need to show that it follows Pythagoras theorem. Triangle ABC is a right angled triangle. Alright, remember this part very important. You need to write this down. So you need to write this square is equals to what? This C square is equals to what? And if they are equal, they are right angle triangle. If they are not equal, then they are not a right angle triangle because of Pythagoras theorem. Or to be more specific, converse of Pythagoras theorem. So let me change another color. Hopefully it's dark enough. Okay, calculate the area of the cut ABCD. Oh, this is actually, you don't even need to use sine or cosine rule. So part C is very simple. You just, since this one is a right angle triangle, we just do half base times height for everything. So we just take this triangle halfway times height, and we just take this triangle halfway times height. That's all. So half times 12.3 times 10.5 plus half times 6.3 times 8.4. Alright, and my answer will be 91.035. I would assume it's cm square. Yep, and this will be my answer. And just take note, I did not write to how many significant figure because this one is an exact answer. Alright, this will be all.